staying at home. My mom had called me out by then.
You got back in the combine and didn't come to class. The day of the combine?
I have a one-way ticket to see us.
All right, my friends, here we go. First of all, before we start our new notes, Owen Pack. We have this conversation every day.
No, I forget it's on my head sometimes. Like it's too comfy.
It is comfy, I get that. Okay, so it's time to talk about our spring paper. Remember you wrote a paper last semester? Gonna write another one. This one is due April 16th. April 16th. As before, it will be one page or more, if you want to go more, but a minimum of one page. Now, what is this paper about? Well, again, it isn't anything to do with math, nothing you're going to, chat GPT or whatever you people do, not doing any of that, because you are going to choose something to do during Lent, and if you're not like a religious person, you don't want to have anything to do with that, okay, that's fine. Don't put it in a religious context. For the next 6 weeks, I would like you to think about one small thing that you can do at least weekly. So maybe every Monday, you fix dinner for the family. Or every Thursday, you take your little brother to soccer practice. Or every Wednesday, you help your little sister study for her spelling test. You're gonna pick something small that you can do to help someone else. Maybe it should visit your grandma every Sunday afternoon. Something that's going to improve someone else's life. Something small, you're making a small sacrifice of your time, and you're going to go help somebody, do something repeatedly. So this isn't a one-time shot. This is something you're going to do at least weekly, okay? Due April 16th. You will, in your paper, tell me what you did, obviously, and then you're going to talk about the impact it had on you and the impact it had on the other person or people, whatever your situation is. All right? So even if you're not Catholic, don't believe in all that stuff, it's okay. You can still do something good for someone, right? That's what this is about. This is about helping someone out. If you need help brainstorming something you can do, I'm more than happy to help you. If you have any questions, I'll put the formal prompt and everything in Canvas, but I just kind of wanted to give you a heads up now, because Lent starts Wednesday. So I want you to be ready when, because that's when you should start, doing your, whatever it is you're doing. All right, we good with that? So like before, 20 points, 20 test points. And 5 for putting it into Canvas. You won't get a grade unless you put it in Canvas. It's got to go into Canvas, but I'll give you 5 extra points for doing that.
You also want a graded copy?
Oh, absolutely. Yeah. And from the first semester, I will actually read it. Please don't make it up. Please actually do it. Right? That's, let's just do it. Thank you. Okay. Now we're talking about the tangent. He actually goes through a whole bunch of conversation in the notes, and I guess that's good because we know what the tangent is. What is tangent? Y over x, or sine over cosine, and it is directly associated with slope. Tangent is y over x. Delta y over delta x is slope. So tangent and slope are directly related. So he goes through a very nice conversation in the notes here about the tangent having slope, sometimes positive, sometimes negative, or not the tangent, the slope. So the tangent, sometimes being positive, sometimes being negative. There are a couple of points though, and I think we've talked about this, but I really can't remember. that are problematic. So in the middle of the page, he says, when theta is pi over 2, the angle is vertical, right? So now I have a vertical line. And what do I know about the slope of a vertical line? Undefined. So what does that mean in terms of the tangent? Well, the tangent of pi over 2 is undefined. There is no tangent. But today we're graphing the tangents. When something is undefined, it has a vertical asymptote. So the tangent will have a vertical asymptote at pi over 2. So here's pi over 2. There's a vertical asymptote for the tangent. Will there be any other vertical asymptotes? Think about that for a second. Vertical asymptotes happen when you're undefined. Where else is the tangent undefined? 3 pi over 2, so here's pi. There's 3 pi over 2. Would there be any other places where it would be undefined? What?
5 pi.
So every half pi, basically, because aren't the half pi's the up and down? So every time you have a half pi, including a negative half pi over here. So like the sine and the cosine, the tangent's gonna go on forever and ever. But unlike the sine and the cosine, it is not continuous. It is broken up into pieces because it has all these vertical asymptotes. Okay, now, what happens halfway in between? So for the tangent, they give you a unit circle. The top and the up and down, these guys are undefined. What happens if these guys, what is the tangent out here? 0, because this is horizontal, and what's the slope of a horizontal line? 0. Tangent is slope. So all of these are zeros. Now all that conversation that he has in there talks about in the various quadrants, is the slope positive or negative? So think about drawing an angle in quadrant 1 like this. Is the slope of that positive or negative? Positive. So in quadrant 1, between 0 and 1, the tangent is positive. Let's look over here, since I've got that piece drawn in there. This is quadrant, what quadrant would that be? 0 to negative pi over 2. Quadrant 4? Isn't that down here? Isn't this 0 to negative pi over 2? What's the slope of that line? Negative. So in quadrant 1, we're positive. In quadrant 4, we are negative. So there is one branch of the tangent curve, and that's what it looks like all the way through. Over and over again. In quadrant 1, positive slope, 2 is negative, 3 is positive, 4 is negative, and so on and so on. So that's your tangent. We can adjust the tangent the same way we adjust our sines and cosines, by sticking numbers in. So this is y equals tan x. If we put a number out in front, and we have to be careful because we can't really talk about it as amplitude anymore. Amplitude was the height, the distance, half the distance from the top to the bottom. We can't really do that with a tangent because there is no top and bottom. But that number, don't call it amplitude, a number right here, that number would have what impact on my graph, Alex?
It determines where the point will be at pi over 4 and negative pi over 4.
Exactly. I mean, it's a vertical dilation. So at pi over 4, what Alex is referring to is, at pi over 4, we know the tangent is 1. We should know that. about your unit circle, what happens at pi over 4? What do you know about x and y? They're both the same, and so when you do the tangent, it's going to be 1. Alex says, if you put a number out there, I'll put a 3 out there. What does that do? That vertically dilates your picture. It multiplies every y by 3. So instead of being 1, that would now be up here. So what's it doing to your curve? It is actually like straightening it. It's making it rise faster. So that number still is going to impact your graph. But don't call it amplitude. It's a vertical dilation. Okay? What about a number here? What do you think a number right here would do? That's a horizontal dilation. That's going to change your period. Now, here's the first, well, this is totally different. Here's a big difference. The period of the sine and the cosine is 2 pi. So when you're doing a cosine equation, and there's a 2 there, to find your period, you take 2 pi and divide it by 2, because the standard period of a cosine is 2 pi. The standard period of the tangent is this, isn't it? Or this, or I don't care what section you look at, but how wide is it? Not 2 pi, but pi. So if I put a 2 in my equation, then the new period will be pi over 2, because it's the standard normal regular period, which for tangent is pi, divided by whatever that number is. Okay? And then what happens if I start adding and subtracting? Well, if I put, let's say we had what is that going to do to my picture? It's going to move it left. Now, it's going to move it left pi over 4. Now, you guys, be careful. What happens at the regular origin in a tangent curve? You have a dot, right? You have a 0. So now that dot that used to be right here is now going to be back here. Does that make sense to you? You're moving your origin. This was the old 0. It's now getting moved left pi over 4. Now, there'll be an asymptote. This isn't in your notes, I'm just trying to build on what he wrote here. There'll be an asymptote over here and an asymptote over here. Would you agree with that? And a curve, a regular old tangent curve, that goes up this time through that point right there. Now, have I changed the period of this problem? No, there's no number in there, so the period's pi. So how could I easily figure out where my asymptotes are? If the period is pi, then how much is this? Pi over 2, or 2/4. So I'm going to back up 2/4 and go forward 2/4. Is that okay with everybody? If you put a number on the end of vertical shift, then it does the same thing it did before. It now moves my axis up to here. And instead of that point being on the x-axis, that point's going to be right there. Will that impact the asymptotes at all? No. It just makes the point of inflection up here. Notice on the tangent, I can call that a point of inflection because this part of the tangent is concave down, and this part is concave up. So that is a point of inflection. All those are. Okay, ready to tackle some of these? All right, here we go. Example 1 on page 2. He drew the picture. And he wants you to find A, B, and D. All right, so take a second with your partner, thinking about the conversation that we have had. Look it over. And we're finding A, B, and D.
It's 2 pi over 4.
No, where'd you get the period?
All right, how are we doing? Let's touch base here. Anybody have any thoughts on A, B, and D? Anybody have any thoughts on any of those? What do you think?
1, 2, and 0.
He says 1, 2, and 0. I see some nods. We're in agreement? Let's go piece by piece. How did you know that was a 1?
I went like halfway over, and it's the widest one.
I put the regular tangent back up here, and we talked about before that at pi over 4, so halfway between my 0 and my asymptote, the value of the tangent is 1, because y and x match there. So somebody out there looked at the point halfway between 0 and the asymptote would be pi over 8, and it looks like that y value is 1, right where it's supposed to be. So therefore my vertical dilation, well, I haven't really had one, it's 1. Good. How about this? Is that 2? Yes, because the period of the picture he drew, and you can go asymptote to asymptote or dot to dot, it doesn't matter. The period is pi over 2. What's it supposed to be? Pi. So obviously we divided by 2. And then how do we know that's a 0? Because we're going through, we're going through the origin, right? Right where we're supposed to be going. It's not moved up here. We're not going through up here like that. We're going right where we're supposed to go. Awesome. Okay, number 2. What is the period of the function that he wrote the equation for? Pi over 2. How do you find the period of tangent? Pi divided by b. Alright, let g be the function. Which of the following gives the vertical asymptotes? Now notice, infinitely many answers, because how many asymptotes does a tangent have? Infinitely many. So you're just coming up with an expression to describe. So take a second and see what you think there. Alright, when I had my tangent graph up here, you observed that all the half pies, so 1/2, 3 halves, 5 halves, we had an asymptote. This is where the asymptotes are on the original tangent, would you agree? So if I had to summarize that, I could say, well, I'm just going to take my first positive asymptote, which is pi over 2, and add pi's to that. So this is pi over 2 plus 1 pi, pi over 2 plus 2 pi's, and so on, positive and negative. So that's how I would write it for the regular tangent curve. All right, now, what's happened in the equation that he gave you? What? The period now is 3 pi. So that means all of your x's have been times by 3. So where's that first asymptote now? That first asymptote will be at 3 pi over 2, right? And then how far apart are they? They're no longer pi apart, now they are 3 pi apart. So it looks like the answer is C. Remember, when you put that 1/3 into the problem, that's a divider. So your everything X oriented in your problem is now being times by 3. These are X's. These were labeled on the X-axis. These are X's. So all of your X's are getting times by 3. Okay? Alright, next one, here we go. Which of the following equations could be the expression for K? So one of those is the equation for the picture that he drew. Well, it's not B or D, right? How can we tell right away it's not B or D? We're down 1, not up, or we're down 2, not up 2, so cross those out. So what do you think? Is it A or C? Oh, I heard both. It's gotta be A, because what happened to our period? Didn't our period get bigger? Right? So that has to be divided by a half, which is times 2. That makes sense, Cole?
I said that.
Oh, you did?
Yeah.
Somebody said so. All right, is everybody good with A? All right, example 5. We're actually going to do this right now. You're all going to do it. You're going to put your answers on the board, and I want to see everybody working because it was disappointing the number of people that missed unit circle stuff on the quiz. That is inexcusable, right? So let's practice again. And you can come up and put these on the board after you get them figured out. They're all tangents. So remembering that tangent is y over x. You know your points on your unit circle, so you should be able to do this.
Yes. I don't know. You should have been great. I took these literally yesterday, though.
I thought I put the grades in.
I was one of the ones that took it yesterday.
I know, I said I graded them, I thought.
I can check again. Maybe I just didn't get a notification.
No, I didn't put them in, I graded them, so I got to put those in.
You're fine.
I know I graded it. It's probably in my routine, and I don't have it. All right, when you have answers, let's go ahead and put them up here. You can put up a couple. See if we get all these right. All right, I'm gonna disagree with a couple of them.
Oh, yeah. A is wrong, yeah.
All right, now I feel a little bit better. How about the rest of you? Anybody have a question about that? I think we should, but I don't think there's a penalty for not. Everybody good? All right, go to the back of page 3. We don't have all of the things we need, so we're gonna do all of this. Then we'll look at question number 9. And 10. And 11. What is the domain of the tangent? What is the range of the tangent? Now, for sine and cosine, it was easy because the domain of sine and cosine is negative infinity to infinity, but not tangent. So how are you going to describe the tangent domain? Think about it. Alex, come up and write on the board. How would you describe that? The domain of the tangent. While he's doing that, what do you think about the range of the tangent? What's the range of the tangent? Negative infinity to infinity. So the range is easy. What makes the tangent domain complicated is all those dumb asymptotes, right? So Alex is going to show us how he would express that.
Shut up.
Pat, where were you this morning? Are you not in the locker?
Okay, so what we have up here is a great start. We have basically one period of it. Would you agree that that's right for one period of it? Okay, so let's Gabby?
So think you do like plus pi over k, or pi k, where k is an integer? Is that-
I don't know.
This is what,
Yeah.
you already came up with an equation for the asymptotes, so can we just say like everything find that?
So that's it. Now the problem with that's going to be, Alex, so what if k is 2? Then it's not an asymptote. It would have to be an odd number. Would you agree with me? Yeah. So let's come back to what Cole said. We need to start listening to Cole. He actually got a perfect paper yesterday, so we have to kind of listen to him. I know.
I don't know how I did.
You did great. You should
Like that,
try to
bro.
learn stuff. I didn't
I mean,
need it.
not wrong.
Cole said, we already came up with an expression for the asymptotes. So could we just say, x can't be pi over 2 plus or minus pi k, I'll use his number where k is a whole number. That would probably be the most effective way of doing it. It's not an interval, so it kind of makes me uneasy. But we're gonna run into some real issues if we try to do that. We could probably do that, but I think this is fine. Basically what you're saying is the domain is everything except the asymptotes. And Alex, you see how the oddness is gonna be built in, because we're at 1/2 plus
Yeah.
1. All right, and then finally, on which intervals is the graph concave up and concave down? So I erased my tangent. But let's just look at this period of it. Where is it concave up? From 0 to pi over 2? Where is it concave down? From negative pi over 2 to 0. So basically, the thing's going to be concave up anytime an angle is in quadrant 1 or 3, and it's going to be concave down when it's in 2 or 4, any angle in those areas. All right, check your understanding. Next page, you and your partner, let's do all of these. Check your understanding, page 4. skip the one that confused you out and keep going.
Like I didn't know
Well, asymptote of fiber two. Make the negative
Okay, here's some conversation about number 2. Explain why it's increasing from negative pi over 2 to pi over 2. Yeah. Anybody have a thought on that? Oh, exactly. At negative pi over 2, first of all, that's on the vertical, right? But it's on the negative vertical, so the slope is undefined. It's like infinite. It's like negative infinity. Straight up, the slope is positive infinity. So to get from negative pi over 2 to pi over 2, you're going from a slope of negative infinity to a slope of positive infinity. That means you're going up, right? You're going up. You're going from negative infinity to positive infinity. Good. The slopes are going from negative infinity to positive infinity. Perfect. You should have A done, or one done. What did you get for your 2 tangents there? 7 pi over 6, the tangent is?
1 over root 3.
Right. I said root 3 over 3, but that's the same thing, 1 over root 3. And what is it at 5 pi over 3? Negative root 3. Very, very good. So those are your unit circle questions. I know they talked about the slope of the terminal ray, but remember, what's tangent? Tangent slope. Right, tangent slope. Those words are interchangeable. All right. What transformation occurred? So 3a, what did we do? What happened in that equation? The period got doubled? Why? Because we divided by a half? So the period got doubled. Does that make sense to everybody? What is the period of a normal tangent? Pi. What would the period of this tangent be? 2 pi. And that was the question. For which values of theta does f have vertical asymptotes? Now, where does it normally have vertical asymptotes? Negative pi over 2 and pi over 2, among other places. So all that got doubled, so where are they now? Negative pi and pi? And 2 pi on our graph, that's all we have room for. So you should have an asymptote here. Oh, no, you also still have one, no. Negative pi and pi. Something's not right here.
No,
it's
sure,
not
one.
one.
This should be,
It would be 3 pi.
yeah. I ended my picture. Wrong spot. There we go. There we go, that's better. All right, now, did you sketch it? Did this point change? Nope, because we didn't move it sideways. How's that look, okay, everyone? Now, where is the 1?
negative 5 Pi over two.
pi over two, this is gonna be negative one. Okay, now you're gonna practice a little bit with your partner. So on the back of that page and then on the successive pages there are all kinds of problems. And the idea is that you and your partner do them like a little quiz. We're not gonna do a trading part. Just work with your partner, start looking through these and let's see what kind of answers we come up with. The answers are not provided, so we'll have to share. We'll check with each other. We'll get as many as we've done as we can before the end of the period. And, shoot, I should have labeled these things. Oh, well, I didn't. No, yeah, you're just writing the answers, there's nothing to match. This is like a whole bunch of different flashcards, kind of like, I just didn't cut them all apart. And we're supposed to cut them out and walk around the room, but we're not gonna do that. We're gonna check with our partner.
Oh.
No, I think it should be. It is. So this is two. And the one pi part. No. So yeah, this one's divided by. Lower fractions of that, but then oh, wait, I looked at it.
But then you have to divide that by five.
No, you're right. I looked at it. Yeah, it's on there.
let's talk about a few here before we run out of time. First one, what did you get for the first one? What was your p-value? 1/2? Everybody get 1/2? Okay, now the one right to the right, or that way, yeah, that one right there. What did you get for that one? 4? P-value 4? How about the next row? What did you get for the first one in the next row? 2? And how about the one with all the little grid things there? 1/3, very good. Are we set on those? Those are all kind of the same problem. We good there? Okay, how about the bottom row? What did you get? Because you got 2 answers. Well, what are they? And then which one's steeper? 2 pi over 3 or 5 pi over 6? Which one's steeper? 2 pi over 3? How could you just know that? I said figure them out, and you could do it by figuring it out, but how would you just know that? Think about your unit circle. Exactly. The closer you are to the y-axis, the steeper you're going to be. And then how about the last one on this page? Which one? A, B, and C? Are all have a slope less than 1? Where is the slope exactly 1? Pi over 4. Anything less than pi over 4 will have a slope less than 1. Does that make sense to you? Pi over 4 has a slope of 1. So here's my unit circle. Here's pi over 4. That slope is 1. If I'm bigger than pi over 4, my slope is going to be closer to infinity, so it's going to be bigger than 1. Here it's going to be closer to 0, so it's going to be less than 1. So which of those angles are less than pi over 4? Only A. Kids, 4/16 is a fourth. Fred is not buying it. Get your calculator out, Fred. Put it in radians and type in tangent 5 pi over 16.
If one of these options was like 9 pi over 16, that would be true, right? If it was negative,
Yeah. What happened, Fred? Clear anyone? Okay, so does this make sense to you, what I'm saying? At this point right here, y and x are the same. So that slope is 1. This slope is basically infinity, undefined, infinity. The closer I get to that, the closer my slope is getting to infinity. So if I'm bigger, my angle is bigger than pi over 4, like pi over 3, pi over whatever. Then my slope is going to be closer to infinity. This slope is 0. If I am this way, my slope is less than 1 because it's getting closer to 0. Well, this is 4/16, 1/4. So these are less than 1, these are greater than 1.
Would we say that on that other side of the y is also less than 1?
Yeah. And you gotta be careful, yes, because but those are gonna be negative, so they're automatically gonna be less than 1, technically. So when we have that conversation, we're not necessarily comparing it to 1, then we'd be comparing it to -1 over there. But then again, with negative numbers, you have to be careful, because less than -1 would be like -2, but -2 is a steeper slope than -1, so it gets kind of tricky when you make it. Okay, let's do a couple more. What's the tangent of 5 pi over 4? Did you get that one? +1. What'd you do with 11 pi over 12? They messed that up. You can actually find the tangent of 11 pi over 12 exactly. That is without a calculator, but we haven't learned that yet, so we're just going to skip that one. You would need to type that in on your calculator at this point. We will learn how to do that, but we can't right now at this moment. Okay, how about tangent 2 pi over 3?
Undefined. Wait,
Undefined?
oh, what? 3 pi over 2, sorry.
3 pi over 2 would be undefined. What's 2 pi over 3? Over here in quadrant 2, that's your 60 or your pi over 3 angle. So it'd be negative root 3. And how about 7 pi? We'll stop there. What about 7 pi? 7 pi's over here. So that would be 0. Our 3.8 homework is going to be due on Tuesday. All right, 3.8 is going to be due on Tuesday. We'll do a few more tangent problems for practice, but you can do this homework. So 3.8 due on Tuesday.